Hello everyone, welcome to our channel Euclid Mathematics. Today I am here with my new videos on real analysis. In my previous video, I will explain to you all Weierstrass EM test. After of that EM test, all these tests are important to find out whether the sequence of a function, series of function, which is uniformly convergent or not. But in my today's lecture, I will explain to you all what is meant by Dirichlet test. Actually, Dirichlet test, it is useful for finding whether our series of a function which is uniformly convergent or not. In my previous video, I explained to you on Weierstrass EM test. In our Weierstrass EM test, we generally used to find bigger sequence than our given series, okay? And then we are trying to guess that our series is uniformly convergent or not. So in my today's video, I will explain to you all Dirichlet test for finding uniform convergence of series of function. Okay, for understanding Dirichlet test, we need to understand first of all 2 points, which is the 2 points. One is the uniformly boundedness and second one is the sequence of partial sum. Okay, then we go through the Dirichlet test for uniformly convergence. So now let's get started for series of function and its sequence of partial sum. So here series of function, it says that e of nx be a sequence of a function. So we have a sequence of function e of nx on given interval I, then series of a function e of nx, it can be written as, we know that this series is represent sum of all these functions present here. So e of 1x plus e of 2x plus e of nx plus so on. Okay, so it is the sum for all n function. Now we want this sequence of partial sum for that series of function. Okay, we always find out the sequence of partial sum for a series of function. Okay, now sequence of a function for first element, if we represent it as the s1 of x, which is equal to f1 of x, that means only first element, and it is a sequence of partial sum itself. Okay, now for the sequence of partial sum for a second s2x, okay, second s2x, it represents the sum of a sequence of partial sum for first function plus second function. Okay, and similarly we continue it sequence of a partial sum for nth function, it is the addition for all n function which present over here. Okay, so this is the sequence of partial sum for n function, which is the Sn of x. Okay, then Sn of x called as the sequence of partial sum. According to sequence of partial sum, series of f n x converges pointwise or uniformly. Okay, so this is useful to find out whether our series of function which is converges pointwise and converges uniformly or not. Okay, now let's get to the next point, which is a uniformly boundedness, which we need in a Dirichlet test. So you can see it here, the definition for uniformly boundedness. It says that if we have sequence of a function e of nx which is said to be uniformly bounded. Okay, so when it is uniformly bounded, if there exists m, it is the constant from natural number. Okay, if there exists m such that that sequence of a function, okay, which we need a positive, that's why modulus here, that sequence of a function e of nx which is a smaller than or equal to m. Okay, that means lesser equal m, and m it is here from constant, some constant from natural number. Okay, and x is belongs to interval and n is from natural. Okay, it is m is that. Okay, now here it is the definition for boundedness. Okay, uniform boundedness, and it is boundedness, it says that we have to find out only the one constant which is bigger than our sequence of function. Okay, so here we need only these two definitions, uniformly boundedness and a sequence of partial sum. Okay, now let's get started to our Dirichlet test. Okay, so Dirichlet test is more stronger than Weierstrass test. Okay, so in my previous video I explained to you all Weierstrass test and some of the examples depend on it. Okay, now in my today's video I will explain a Dirichlet test because it is more powerful than Weierstrass test. Okay, so let's get started to our Dirichlet test. Dirichlet test, it says that if series of function e of nx can be written as a product of a two function. Okay, so that means if we have given series of function e of nx in our example, so we have to write into two parts. Okay, so series of function can be written as, we have to write that one as series of unx into vnx. Okay, these two different functions. Okay, so I expanded it as a series of unx into vnx such that it need to satisfy two properties. Okay, so first property, it says that one of them that function is to monotonically decreasing. Okay, what is meant by monotonically decreasing? It is decreases slowly. Okay, so it is monotonically decreasing, it's going smaller and smaller and up to smaller when it converges to 0. Okay, that means when we apply limit n tends to infinity, one of the sequence of function here, that goes to 0. Okay, so it means by uniformly converges to 0. Uniformly means we have to apply limit n tends to infinity, one of them. Okay, and when it land on 0, then we say that converges to 0 as a uniformly. Okay, and now second point, it says that sequence of a partial sum one of the other property. Okay, so if we consider Vnx, it is here, we have to consider Unx here, or if we consider Unx here, we have to consider Vnx here. Okay, so for series of Unx, it need to be uniformly bounded. Okay, uniformly bounded means our series which is bounded by some of the constant value, and it is the sequence of partial sum. Okay, for that series, then we say that that series of Nx, which can be written as Unx into Vnx, which is a uniformly convergent. Okay, so it's quite trickier to understand directly the definition and properties for Dirichlet test. Okay, but it's more easier when we solve some of the examples. Okay, so let's get started to the examples also. That means here series Unx into Vnx, okay, which we consider Fnx is a uniformly convergent. So let's hear example first. Series Fnx, I took it here, minus 1 raised to n minus 1 upon n plus x square. And these x belongs to real r, okay? So our definition for Dirichlet test, it says that we have to expand our function in the form of a two function, okay, which is Unx into Vnx, okay? So I expanded here in the multiplicand form. We have to write this is in the form of a multiplication. Remember it always. So minus 1 raised to n, it is here, n minus 1, multiplied by Vnx 1 upon 1 plus x square. And we have to work for these two property. One of the property, it says that it is monotonically decreasing and converges to 0 uniformly. And second property, it says that sequence of partial sum uniformly bounded, okay? So as we observe our example, we can see that monotonically decreasing and uniformly bounded, okay? Monotonically decreasing and converges to 0. We can see that this one, if we apply n tends to infinity here, it goes to easily 0 than this one, okay? So that's why we have to consider Vnx as this. Because of that, if we apply limit n tends to infinity, our first property satisfied here, okay? So Vnx is 1 upon 1 plus n plus x square, and Unx is here minus 1 raised to n minus 1, okay? Now let's apply the first property, that monotonically decreasing and converges to 0 uniformly, okay? So Vnx 1 upon 1 n plus x square is a decreasing. Why it is decreasing? As we increase n here, that goes to smaller and smaller, okay? Vnx goes to smaller and smaller. And when we apply limit n tends to infinity, that Vnx goes to 0, okay? That means it is a converges to 0 uniformly, okay? That means it says that our first property hold here for our Dirichlet test, okay? Monotonically decreasing and converges to 0 uniformly. Now let's go for the second property, okay? And second property, it says that it's a sequence of a partial sum, okay? Sequence of a partial sum, that means we are finding sum of its nth term of term which present in our series, okay? So we can see that Unx is equal to minus 1 raised to n minus 1. If we expand that series, we get the 1 minus 1. When n is equal to 1, 1 minus 1, 0. Then any term to the power 0, which is 1. 2 minus 1, it will be 1. Then minus 1 raised to 1, it remains minus 1. Similarly, apply for n to nth value here, okay? So I got it here. Unx is a 1 plus minus 1 plus 1 minus 1 plus minus 1 raised to n minus 1, okay? As we increase this one, okay? So we can see it here. It seems like that if n is even, for the even value of n, we get the value 0. And for odd values of n, we get the value 1, okay? So it gives us 0 and 1 value only if we apply n, different n here, okay? So that means it has a sequence of a partial sum. It is uniformly bounded, okay? It is bounded by 0 and 1, okay? So we see it here that upper value is 1 and lower is 0. So our sequence of partial sum, it cannot exceed than 0 and 1, okay? So here it is uniformly bounded by 0 and 1, okay? So both condition of our Dirichlet test is hold here. Then we can say that series Unx into Vnx, which is a minus 1 raised to n upon n plus x square, is a uniformly convergent on R, okay? So this one is an easy test that we have to decide whether our sequence or series of a function it is uniformly convergent or not, okay? And it is applicable for pointwise convergent too, okay? So I hope so you all have understood my today's lecture. So for more example, you can see it into my playlist. So we will go for the more example in my next lecture. Okay, thank you for my today's lecture.